Welcome to the Calculus on Y Canvas. Today we will go over the definition of derivative and its simple application of very typical calculus problem, that is finding the derivative by the definition. Let's derive the definition of derivative. A typical way of deriving the definition of derivative is to use the slope of a curve. Let's say we have a function f defined on one-dimensional real line. Pick 2 points A and B and connect the corresponding points on the curve and form a secant line. The slope of the secant line is the change of function value over the change in x value. Mathematically, we can write the slope of the secant line between A and B to be S of AB equals F of B minus F of A over B minus A. Now let's fix the point A and move point B closer and closer and closer and closer to A. What do you observe? Do you notice that the secant line is converging to the tangent line at point A? This implies that the slope of the secant line is converging to the slope of the tangent line at point A as point B approaches to point A. This can be written mathematically as f prime of A equals limit B approach A f of B minus f of A over B minus A. If we explain this term by term, f of B minus f of A over B minus A stands for the slope of the secant line between A and B. Limit B approach A stands for the limit as B approaches A. Finally, f prime of A stands for the slope of the tangent line at A. By the way, what does this limit definition of the derivative really mean? Let's look at the ratio in the definition of the derivative again. If you make B equal A, then the top and bottom of this ratio becomes 0, that is 0 over 0. However, from the example of the slope of the tangent line, if we take the limit, we know that f prime of A equals the slope of the tangent line, which is not obviously 0 over 0. Therefore, we know that the action of the limit is not actually making B equals to A. Instead, the action of the limit brings point B very, very, very close to point A, but never touches point A. This limit action makes the top part very, very, very small change of function f, which we call it the infinitesimal change of f, while the bottom also becomes very, very, very small change of x value, which we call it the infinitesimal change of x. Therefore, the derivative can be formally defined as the infinitesimal change of function values and the infinitesimal change of the domain values. Now let's modify the definition of the derivative by the change of variable. Let's define variable h to be the difference between a and b, that is h equals b minus a. This makes b equals a plus h, and we see that h approaches 0 as b approaches a. Therefore, we can rewrite the definition of the derivative as f prime of a equals limit h approach 0 f of a plus h minus f of a over h. All right. These two equivalent definitions of the derivative will be handy to solve many calculus problems. For example, let's say you are asked to find the derivative of a certain function, say f of x equals x squared. If you know the power rule, then it is easy to find the derivative. But if you forget the formula, you can always go back to the definition of derivative. By the definition of derivative, f prime of x equals limit h approach 0, f of x plus h minus f of x over h. Plugging x squared in the place of f of x, we get limit h approach 0, x plus h squared minus x squared over h. Expanding and simplifying the numerator, we get limit h approach 0 to xh plus h squared over h. Canceling the h, top and bottom, we get limit h approach 0 to x plus h. By taking h approach 0, we ended up with 2x. This implies that the slope of the tangent line of the function x squared at point x is given by 2x. There are many other applications of the derivative definition. For example, you can find a limit of many 0 over 0 forms using the derivative definition. If you are interested in that trick, you can click the link in the description below. All right, I hope this lecture was helpful. Please don't forget to push the like button and share this video with your friends. More calculus lecture will be coming soon, so please stay tuned and do not forget to subscribe. All right, see you next time.